This video will highlight some of the additional features of our Mars data analysis software. We hope that this will help you to begin maximizing the potential of this data analysis tool. Our example is spectral data from DNA detection on our LVIS plate. With this type of data, you can select any of the wavelengths read to be presented in the data view. If we look at the spectrum of a representative well, we can use this to show how spectral ranges and wavelengths can be used. Clicking New Range adds a range which can be adjusted by dragging the range indicator. Alternatively, clicking Ranges allows you to adjust the range wavelengths by clicking the arrows in the display or simply typing in the desired value. Clicking Wavelengths opens the Manage Wavelengths window. Wavelengths can be added at maxima or minima, or simply by typing in the desired wavelength value. Click OK to add the designated wavelengths. As each wavelength is added, it appears in the Available Data pane. We can now start to use these wavelengths and ranges in calculations. First, let's look at a spectral calculation. We can select the previously defined range and calculate its average to obtain a discrete value for this range. Now, let's use some data calculations. We can subtract the calculated average of our range from the defined wavelengths as a sort of background correction. To perform these types of data calculations, you need to select the input data and wavelength when needed, as well as the desired operation. Then click Apply. We can perform this calculation for both of the indicated wavelengths that we wanted to look at. One final data calculation. Select the corrected 260 and 280 values with division as the operation. This will allow us to calculate the 260-280 ratio. As you can see, each time a calculation is completed, it appears in the available data pane. Since the 260-80 ratio is used as an indicator of sample quality, it provides us with a good example to use in validation. Select this ratio calculation as the input. The passing value for DNA quality is a ratio of 1.8. Anything below this is of questionable quality, so we can indicate this as a failed sample. And everything above 1.8 is passed. Colors are a useful way of drawing attention to these validations. And the values can be added to further accentuate this. The last type of calculation that I want to show you is the user-defined formulas. With this, you can really use Mars to suit your needs. In this case, we will use the simple calculation of DNA concentration as an example. Select the 260 that is corrected for background, add an input with an X, and then multiply by a fixed value of 50. This is the extinction coefficient for double-stranded DNA when it is quantified in units of micrograms per milliliter. Give your result a name, and click Apply and Close. And you can see the table now holds the calculated concentrations for each of our samples. Once you are satisfied with the calculations in your current test run, you can create a template. Click Create a Template from Current Test Run. The template can be given a name, and you can review all of the steps that will be performed in this template. Click Create to finish. If we open a test run with the same type of data, we can apply this just created template to that data set. Click Assigned Template to Current Test Run, find the desired template, and click Assign, and then confirm that you want the calculations to be changed. Again, the first thing that is shown is the DNA concentration in micrograms per milliliter. Of course, BMG has included some templates which are very useful. For example, the double-stranded or dsDNA template is most likely going to be sufficient for anyone performing DNA quantification, as it contains all of the calculations and validations that were just performed. Of course, there are many other Mars capabilities. If you have questions about how Mars can help you with your data analysis, please contact us.